So we're going to move on to the next section in our mid-chapter break that we're doing here. And we're going to move on to something called factoring. Factoring is going to take us quite a while to get through, and we're going to do one specific type of factoring today. So the big question for today is how are you going to factor by using something called the greatest common factor? And usually they refer to this as GCF. And you've probably heard of greatest common factor before, or GCF. I can give you an example. If maybe like in 4th, 5th grade, if you had like 15 and 25 and said, what's the greatest common factor between these two numbers? You're trying to think of the biggest number that both of those numbers can be divided by, right? So you're trying to think what goes into 15, what goes into 25, and that answer would be 5. So the GCF of those two numbers would be 5. So we're going to practice doing that with numbers, and we're going to do it with variables, and we're going to talk about how to do it with each one to do some factoring. So specifically with numbers, to find the GCF, you look at all the coefficients. So what does that mean when you're looking at coefficients? If you look at something like down here for number 1, number 2, coefficients are just numbers in front of the variables. So no matter what you have, if you have 3x plus 4x squared plus 7y, it doesn't matter. You're looking at all the numbers in front. These are called coefficients. So you're going to find the GCF of all the numbers that are there, all the coefficients. What does that mean? You're going to find the greatest number that all of the numbers there can be divided by. So this isn't a great example because 3, 4, and 7 is not, nothing works there for a GCF. So let's look at something that does work. What if I had 10, 5, and 20? You could find the GCF between all three of these numbers because 5 would be the one that goes into all of them. All right, now with variables, it's a little different. If you're trying to factor out a variable, you look at the smallest exponent. So whatever's the smallest one. So in my particular case up here, my smallest exponent would be x to the first. However, it has to be in all terms. So in this particular case, it's not in all terms, so you can't do it here. But it'll make more sense when we actually go through this. We're going to start with some problems where we're just going to identify what they have in common and try to pick what GCF is, and then I'll show you how to actually do it. So down to number 1, we have factor each polynomial. So we're going to do 2x plus 2. What do they each have in common? Well, all we can look at here is numbers. There's only one x. We don't have two x's here. So what do they have in common? That would be a 2. 2 goes into both of those. And the second one, 3x minus 9. What goes into 3 and 9? A 3. And number 3, x squared minus x. There's no numbers here, but we can apply the rule that we had up here. With variables, look for the smallest exponent, and we can factor that out. So we have a squared, and we have a x to the first. The smallest one is x to the first. That's what they would have in common. You can only, technically, we're pulling them out of the two terms, and you can only take out the smallest one that they have. You can't take out more than the smallest. How about number 4? 3x minus 2. So variables, there's only one x, so you can't take out a variable. And with 3 and 2, there is nothing in common. So you could say there's 1 in common, but if this ever happens, you cannot factor it. So we call this not factorable. There we go. And so that may happen. You get a problem that you cannot do anything with as far as factoring it. There's no GCF. And number 5, 2x squared plus 2x. Each term, we look at the numbers. 2 can go into both the 2's. And again, x to the first would be the smallest one. So it is possible to deal with numbers only, let variables only, or it could be possible to factor out both numbers and variables. All right, so let's try some. Factoring is a lot like dividing. It is not like subtracting. At least with numbers. So maybe I'll be a little more specific here. It's a lot like dividing when you have numbers. But it is actually more so subtracting whenever you have variables. Whoops. So whenever we take these out, we're going to be dividing by the number that we're taking out with numbers. And then when you have a variable, you subtract the exponents. It's kind of like remember when we did problems like this where we had like 21x to the fourth divided by 7x squared, where you divide the numbers that are here, but you subtract the exponents. So you're really ultimately doing division, but it depends on what you're looking at. Exponents, you subtract, and then when you have regular numbers, you divide. So let's get rid of that. Okay, so let's look at this first example here. We only have variables, so we're going to look for, what is it? The lowest exponent, which is x squared. So we're going to take that out to the outside, and we write x squared, and then you do a parenthesis set, and we're going to write what's left. So since we only have exponents and variables, we're going to be doing subtracting. So this is how you do it. You do 4 minus the 2 that we pulled out, and you put the answer down here. So it'd be x squared. So there's 2 left. Then you do it again with what we pulled out. You do 3 minus the 2 we pulled out. So minus x, that'd be to the first power. Then you do it again. X squared minus 2, or 2 minus 2, so there's no x's, minus, so you don't have to put this. If that ever happens, you just don't have any x's. But you do have to write something, and that something is 1. So what I did here is I just subtracted 4 minus 2, 3 minus 2, 2 minus 2, and wrote the results down here. And I kept the signs of subtraction between each thing. And you put it instead of parentheses. Now you could check to see if you had the right answer. How would you do that? Well, what we're doing is we're doing the reverse of the distribution property. So if you were to actually distribute this to all 3 things, that would get you back to this answer. This is called factoring, where we're basically like undistributing, taking it out. All right, number 7. What goes into 2, 4, and 6? That would be 2. So we're going to write 2 on the outside. And then let's look at the variables. We have x squared, x to the fourth, x to the third. We're going to take out 3 x's because that's the smallest one we have. And write what's left. So with numbers, we divide. 2 divided by 2 is 1. The variables we subtract. 6 minus 3, there's going to be 3 left. Move on to the next one. 4 divided by 2. Rather, it's negative 4 divided by 2, which is negative 2. 4 minus 3, 1. Move on to the next one. Negative 6 divided by 2 is negative 3. 3 minus 3, there's no x's left. Just end it. So we're going to do a lot of these kind of problems. We're going to do a couple more in this video, but then there's a lot left to do in the notes for you to try. All right, number 8. What goes into 3, 12, and 6? That would be 3. What's our lowest exponent? That's just x, x to the first, parenthesis. Now go through and divide and subtract. 3 divided by 3 is 1. 3 minus 1 is 2 x's left. 12 divided by 3 is going to give us our 4. 2 minus 1, 1x left. And the last one, negative 6 and 3, that'd be a minus 2, no x's. Hopefully I'm not going too fast through this, but I'd like to move quickly through all these problems. And if you need to, just go back and watch it again or watch specific ones. Number 9, look at all the numbers. 5, 20, and 100. The GCF of all those numbers is 5. The lowest exponent is x to the fourth. Divide again, we get 1. We get x squared. Minus, divide them, you get 4. 5 minus 4, there's 1 left. And then 100 divided by 5, we have 20. No x's. 4 minus 4. That's all we're doing. This is called doing the factoring with the GCF. So sometimes you may come across a problem that has all negative signs in it, and that's okay. We can practice also taking out a negative sign with our number. So that's useful to not have negatives everywhere. you can change these in the parentheses to positives, and sometimes that will be necessary. So we're going to practice taking out a negative with this. So we have 5, 5, and 15. I'm going to take out a negative 5, which can go into all these. And I'm going to take out an x squared. Then we write what's left. Divide these. We get, negative 5 divided by negative 5 is 1. X squared, 2 minus 2 is 0. There's nothing there. And then we go to the next one. Negative 5, b plus 1. 3 minus 2, there's 1x. And the next one, negative 15 divided by negative 5. That's a positive 3. 4 minus 2, there's 2 left. So see what happened here? If you divide these two negatives, they're going to change them to positives. All right, number 11. This would be another one where we would probably want to take out a negative just because we have it out front. I also want to practice doing that a couple of times. Sometimes it's better to have this front term here to be a positive rather than a negative, so it just happens to be that way sometimes, and later we'll actually make sure that's actually the case. So right now it doesn't really matter, but I'm going to try practicing and taking out a negative. 3 and 6, we could take out a 3. Now we have multiple variables, so we're just going to look at each one individually. We have a squared and a cubed, so we're going to take out an a squared. And then we have b and b squared, so we'll take out a b. So let's see what we have left. If we divide these by negative 3, we get 1. 2 minus 2 is 0. b1 minus 1, we get 0 there. So this goes away. We just get 1. Then we go on to the next one. 6 divided by negative 3 is a negative 2. If we took out 2 a's, there's still 1 left. And then 2 minus 1, there's still a b left. So what happened on the inside here is the signs changed. All right, we have a couple more left. I think, 4 more? Yeah. For number 12, we have 27, 12, and 9. So we don't actually see the GCF here. We're going to have to figure out what that is. What goes into all those numbers? I believe the highest number would be 3. And then the highest y we can take out would be y squared. There's 2 of those here. But notice in this one, we only have an x in one of the terms. It's not in all 3 of them, so x has to stay in there. All right, let's divide by 3. We get 9. Subtract those, you get 5. Next one, divide by 3, you get 4. Subtract the y squared, so there's none, but there's still an x that comes down. Then do it again. 9 divided by 3 is 3. We took 2 y's out, none left. All right, number 13. 35 and 50. I think 5 is the biggest one. And if you look at all these letters, we have Q in each one. That's the only other thing we can take out. All right, so let's take that out. We get 6. Take out a Q. We're left with a P and an R. 5 divided by 5, we have a minus 1. There's a minus sign there. Took out a Q, so there's just a P left. And then we're going to divide this by 5. We get 10. And there's nothing left because we took out the Q. All right, 2 left, and then we'll be done. The rest of it is the huddle for you to finish. 14. If you see here, we have quite a few negative numbers, so I'm going to take out a negative in this case. What goes into 10, 6, 4, and 8? That would be 2. Well, that's a pretty bad 2 there. All right, what do we have left? We have some y's, so let's take out y to the 7th would be the smallest one. And we have an x here and here, but we can't take them out. It's not in all 4 terms. So in this particular case, we need everything to be in all 4 terms if we're going to take something out. So if you look at this, a term is just considered, what is one term has a plus or minus between them, makes a term. So let's divide these by negative 2 now. So this is going to become 5. We took out all 7 y's. This will become, I guess that becomes a minus sign. Minus 6 divided by negative 2 is negative 3. We took out 7 y's, so there's 3 left. This becomes a plus. Divide them, you get 2. There's still 3 y's plus an x. And then divide that. Negative 8 and negative 2 is a positive 4. We took out 7 y's, so there's 1 left and still an x. All right, last problem. Still 4 terms. Let's see what we can pull out. What goes into all these numbers? And I think it's 7. And the lowest one we have is just 1b, nothing else. So divide all these by 7 and just take 1b out. So that would be 4, no b there, plus 2, take out a b from there, so you have 1 left, plus, divide that, you get 5, and then take 1 away from there, so it's b squared. And then 7 divided by 7 is 1, take out a b, it's b to the 4th. So again, I was trying to go through this quickly, and hopefully you could follow. Eventually, after a while, you'll be able to get it, hopefully, and it'll be pretty easy for you. So after that, you can go ahead and finish the rest of the huddle. So there's quite a few problems left to try. And also, do not forget about doing the warm-up as well. So the warm-up includes distribution property, and then what we did was doing the opposite distribution, which is called factoring. So that'll be all for day 2.